We've already discussed the IS curve in a purely graphical version in an earlier video, but I want to turn now to an algebraic version. Some people like more algebra, see exactly how things work. Some people are more focused on graphs, but I want to make sure that you are able to do and understand both. So we have the same relationship that we talked about before, the goods market, where the general versions, consumption plus investment plus government spending on goods and services equals national income. That's the equilibrium condition up here that's represented in the IS curve. Now I want to put a little bit more structure on the equations themselves that explain the behavior of each of these components. So there's a little bit of, maybe a lot of notation here, but if you bear with me a moment, I think you'll understand what relationships I'm trying to illustrate in these equations. So we have these three versions of three different equations for the relationships that we've got up here. One is the consumption function, one is an investment function, and the other represents government spending. Okay, let's look at these in isolation. So with the consumption function, we have a autonomous level of consumption that's represented by C bar, which is going to be used to represent, for example, consumer sentiment about the future. Changes in optimism or pessimism will change the consumption that consumers decide to undertake, regardless of the national income or interest rates or anything else. Okay, so we get C bar. Here is disposable income. This is income minus the marginal tax rate multiplied times income. So here is disposable income multiplied, let me make sure this is a multiplication, multiplied times the marginal propensity to consume out of income. So give me an extra level of disposable income. This will tell me how much consumption changes. And then we're going to have a new component, which we've not talked about before, but which is, I think, quite intuitive, which is consumers react to the interest rate too, the real interest rate. Okay? Now, if we're abstract from any kind of inflationary pressures, nominal and real interest rates are the same, I want to go ahead and use real interest rates for this version. So what we have here is that consumption will be negative related to the interest rates. Higher interest rates, the less you consume because you can't borrow as much. CR is the consumer sensitivity to those interest rates. So again, the consumption is based on sort of the general consumer sentiment, how much consumers spend out of their current income, and then some sensitivity to interest rates, which reflects borrowing in the market. Investment is going to have, again, some autonomous level, which is going to be related to sentiment, as we're going to see, minus a component that reflects how sensitive investment is to interest rates, multiplied times the interest rate that's actually seen in the market. So this is going to reflect how investors will change their borrowing to expand factories. In fact, this would also include, the investment here would include consumer purchases of new housing and factories. And then we're just going to have government is equal to some amount that's determined strictly by government spending. So we're not going to look at, for example, government spending as it relates to interest rates and so forth. So we're going to set that aside. Okay, so this looks complicated, but if you look at each component, it's I think fairly intuitive. Now what we want to do here is to take these equations and put it into this relationship. So I'm just going to plug in and then try and find an expression that's related to the IS curve. So, we've got C bar plus CY times Y minus TY, okay, minus CR times R, okay, that's just C, plus I bar minus sensitivity to interest rates plus G bar, and that's all going to be equal to national income in equilibrium. Okay, so I've just plugged in what I've already got. Now what I want to do, because I want to do this with the IS curve with interest rates on the vertical axis and national income on the horizontal axis, I want to combine all of the terms involving Y and all of the terms involving R, solve for R, and then we'll have an expression that has the intercept and slope, which we can then interpret. Okay, so first, we've got C bar plus I bar plus G bar. Okay, that's this part, it's this part, it's this part. Okay, so I've got those constants separated. Now let's look at Y separately. Okay. Do this a little bit differently. So I'm going to pull Y out of this. See what I did? I pulled Y out. So Y times CY times 1 minus T. Okay. Minus Y, that's this Y, pull that over here. So we've got this part taken care of, we've got that part taken care of. Now we're left with R. Okay, the interest rate, pull that over to the other side. And what we're going to be left with is IR plus CR. Here's again the sensitivity of investment to interest rates and the consumer sensitivity to interest rates. Okay. Now I want to isolate R. Okay, I'm trying to get this. So I'm going to divide both sides by that. So what am I going to get here? C bar plus I bar plus G bar over CR plus IR. Okay. This is going to be the intercept of the IS curve. It's the part that doesn't vary with income. Pull this over. Okay. Now I want to separate out Y, 1 minus CY times 1 minus T, divided by CR plus IR. Now one thing you'll notice here, what I've done is I've pulled Y out and then put a negative sign here instead of the plus, so everything else here is negative. So 1 minus CY times this is equal to R. Okay, it looks nasty. Take your time, do the algebra, see how that works. Okay, so here we've got a relationship which makes clear what might shift the IS curve, what might change the slope of the IS curve. Okay, so again, the IS curve is going to have Y on the horizontal axis and interest rates on the vertical axis. Now in the previous video I used the nominal interest rate, but here we're just expressing this in terms of real interest rates to to allow for the possibility that prices might change, okay? All right, so then we've got this thing. Let's call this A. This whole thing. So anything that changes A is going to change the intercept. Okay, we'll come back to that in just a moment. This is a negative, has a negative relationship with national income. So what we've got here is the IS curve, where the slope is at, well, actually the absolute value of the slope is 1 minus cy times 1 minus t over cr plus ir. Okay, so let's interpret this for a moment. What this is saying, that if you change, say, consumer sentiment, C bar, if consumers become more confident in the future, they're going to be willing to spend more. That is reflected in this setup as being an increase in C bar. That's going to increase the slope, the intercept, shift that IS curve up. A change in investors' sentiment about the future, the same way. If they are more optimistic, shifts the IS curve up. If they're more pessimistic about the future, it shifts it down. If there's an increase in government spending, shifts the IS curve up. So the things that we've learned about in a previous video about what shifts the IS curve, it's still true, okay? It's just expressed in a bit more formal terms, okay? What about something that will shift the slope of the IS curve? Well, one of the things would be a change in the marginal tax rate. Now, in the earlier video, we talked about just a simple lump sum tax system where that would just shift the IS curve one way or the other. In this more sophisticated version of it, a change in the tax rate will make this slope either bigger or smaller depending on which direction the tax rates go. Let's say that there's a tax cut, a change in the marginal tax rate. Now that is going to be reflected in this component right here. A smaller tax rate, a lower tax rate, is going to make the IS curve flatter. For every given interest rate, the equilibrium national income will have to be higher. Okay? So that's how you would reflect a change in the tax rate in this framework. Well, what else might change the slope? Well, the sensitivity of consumers to interest rates or sensitivity of investors to interest rate will also change the slope. If CR or IR go up, if consumers or investors become more sensitive, that's a bigger number. It means a bigger denominator. This gets flatter. Okay, the S curve gets flatter, but you'll notice it also has this effect over here on the intercept. So either a change, so if either CR goes up or IR goes up, you would tend to have a flatter IS curve. Now, what does that mean? consumers being more sensitive, or investors being more sensitive to the interest rate, means that a small change in the interest rate will have a bigger impact on national income. So let's say, for example, that we compare these two IS curves, and we just have some arbitrary level of interest rates and national income that are the equilibrium in both circumstances. And how do these two slopes, being different, reflect the underlying behavior? If either of these two things is bigger, a small change, a small change in the interest rates will have a big change in the equilibrium level of income, the flatter this line is. So, if interest rates fall a little bit, with the original IS curve, we only have a small increase in national income. But if consumers and investors are very sensitive, that same change in the interest rate will cause a big change in the level of national income associated with equilibrium in the goods market. So what you see here is a number of ways that we can interpret the consumer, investor behavior, government decisions in an IS curve in a more explicit way. So you could provide numbers for these various values and have a specific level of national income that you could derive with those numbers, which would be a good exercise for a homework to allow you to see how these relationships work in a particular example. Okay, so that's an algebraic version of the IS curve, bit of algebra, but has the same flavor of the purely graphical version that we did before.